Welcome back, student. Today we'll discuss on minimum work input. Minimum work input for multi-stage compression. Okay, what is the minimum work input required for multi-stage compression? The condition is given that the cooling process is basically perfect cooling, or it is in the intercooler. Perfect intercooling takes place. Okay. Now, as you know that. The minimum work done required for two-stage compression process for perfect intercooling. Already we have proved these expressions. Like W is equal to P1 V1 into N by N minus 1 into P2 by P1 to the power N minus 1 by N plus P3 by P2 into the N minus 1 by N minus 2. Already it is proved in the previous lectures that this is the minimum work done input required for two-stage compression process when the intercooling takes place perfectly. Okay, and to get the maximum efficiency for a two-stage or multi-stage compression process, the condition is that P2 square is equal to P1 P3, or as such P2 will be geometric mean of initial pressure and final delivery pressure. It means intermediate pressure, if the intermediate pressures is equal to the product of square root of initial pressure and final delivery pressure, then this compressor will give you the maximum efficiency. Okay, now to get this efficiency, the work input will be minimum. Okay, in this case work input will be minimum because you get the maximum efficiency. So P2 square equal to P1 P3, or P2 is equal to under root of P1 P3. So P2 is your intermediate pressure, as you know that P1 is your initial pressure, P3 is your final delivery pressure. Okay, so this is the expression P2 square is equal to P1 into P3. So P2 square is equal to P1 into P3. Now dividing both sides with P1 square. So dividing this equation with P1 square. As you divide, the equation becomes P2 by P1 the whole square is equal to P3 by P1. So P1 and P1 square, that will be cancelled. So in the dividing part, that will be P3 by P1. Okay, fine. Next, so P2 by P1 is equal to P3 under root of P3 by P1. Okay, so we know that P2 by P1 is equal to P3 by P2, right? So P2 by P1 is equal to P3 by P2. So here P2 by P1 is equal to P3 by P1. It is under root of. So P2 by P1, we can write down P2 by P1 is equal to P3 by P2 from these expressions. So P3 by P2 is equal to P2 by P1. So that is equal to this one. Okay. Now, as you know that the minimum work done required, actually this is the minimum work done required for work input required for the two-stage compression process for perfect intercooling. So these are the expressions, as you know that the previous lecture video you already proved on this. Now, in terms of, there are two terms are there, P1 V1 and P2 by P1 and plus P3 by P2. So where here it is that expressions, in this expression P2 by P1 and P3 by P2. Now, so equation becomes, so for minimum work done, required for minimum work done, that will be N by N minus 1 P1 V1. Put that equations in the first equations for work input required for two-stage compressor with perfect intercooling. So that will be in the bracket. So P2 by P1 is replaced with this term P3 by P1 to the power half, means under root of P3 by P1, and P3 by P2. So P3 by P2 in this expression, so P2 by P1. Okay. Now here it is. So P2 by P1 can be replaced with this P3 by P1 to the power half. Okay, and P3 by P2 can be replaced with P3 by P1 to the power half, means under root of P3 by P1. So both we can replace, and if you replace them, so the equation becomes this one. Okay, then these two terms will be added up. So that will be 2 into P3 by P1 to the power N minus 1 by 2 N minus 2. So 2 will be common here, so that 2 will be coming out from that expression. So 2 here, So 2n divided by n minus 1 into P1 V1, okay, into P3 by P1 to the power n minus 1 by 2n minus of 1. So minimum work done required for two-stage compression process with perfect intercooling. So that will be this one. Okay, if it is the compression process in 2 stages, if it is 3 stage, if it is 4 stage, then we will discuss later. So now for the minimum work done required for 2-stage compression process is 2n divided by n minus 1 into P1 V1 in the bracket P3 by P1 to the power n minus 1 by 2n minus of 1. Okay, now as we know that this type of compressor basically air compressor, and air behaves as an ideal gas, where assumption on that, we are just suppose we are assumption on that, so assume on that. Now P1 V1, as we know that ideal gas equation follows that P1 V1 is equal to mRT1 here. So P1 V1 is equal to mRT1. So P3 by P1, the equation becomes 2n divided by n minus 1 into P1 V1, it will be mRT1. So otherwise the equation becomes same. Okay, so it can be written in this manner, it can be written this expression also in this manner. So both are right actually, but it is only applicable for 2-stage compressions. Okay, now if it is 3-stage compressor, if the minimum work done required for 2-stage compression with perfect intercooling, then that will be, then the expression will be, for 3 stages. So that will be 3n, as it is 2 stages, that will be, the expression was 2n divided by n minus 1 into P1 V1 in the bracket P3 by P1 to the power n minus 1 by 2n minus 1. Now that was for 2-stage compression process, right? Now this expression is basically for 3-stage compressor. So for 3-stage compressor, the minimum work done required, that will be 3n, here it is 3 because of 3-stage compression, divided by n minus 1 P1 V1, same. Now that is the number of stage of compressions. If it is 3 stage, that will be 3 plus 1, that means 4. If it is 2 stage, that was P2 plus 1, that will be P3, that in that previous case. So P4 by P1 to the power n minus 1 by 3n minus 1. So for the x number of, if the multi-stage compression process takes place in x number of stages, then the expression 1 x into n divided by n minus 1 into P1 V1. So x is basically number that suggests x will be 1, 2, 3, 4 depending on the number of stages. So if it is 2 stage, that will be 2 here. So P1 V1 2n by divided by n minus 1 P1 V1. So expression, if it is put here 2 here for 2 stage, so and the equation becomes P3 by P1 to the power n minus 1 divided by 2n minus 1. Okay, if it is 3, that will be 3n. So you can correlate this expression. You can correlate this expression, that that the expression becomes here in terms of here x. If it is 3 stage, you can put x in terms of 3 because the number stage is 3. So 3 into n divided by n minus 1 P1 V1 p into x plus 1. So P3 plus 1 means P4 divided by P1. So P4 here, P1 here into n minus 1 divided by x n. X is equal to here, x is equal to here number of stages, that is your 3. So write here 3, so that will be 3. So for x number of stages, the expression becomes this one. Okay, now for the 2-stage compression process, the expression becomes also in other form also. If you can change, as you know that the P3 by P1 is equal to P3 by P1 to the power under root of P3 by P1. So P3 by P1 is equal to P2 by P1 from the previous expression. From the previous expression, you can put this expression in terms of P3 by under root of P3 by P1 is equal to P2 by P1 here. So 2n divided by n minus 1 into P1 V1 here. So P3 by P1 to the power half, that means n minus 1 by 2 into n, that means half into that one, right? So P3 by P1 to the power half, that means equal to P2 by P1. So you can change P3 by P1 under root of P3 by P1 is equal to P2 by P1 to the power n minus 1 by n minus of 1 kilojoule per cycle. Okay, okay. So this is the minimum work done required for two-stage compression process when the cooling process is perfectly okay in the intercooler. Okay, thank you very much for listening and watching me. Goodbye.